number 28. These are all problems from your book, by the way, and you have access to the book. So we've got seeds. We're told the germination rate is 92%. So the first thing we're going to do every single time, identify our population. Our population will be seeds, the successful ones germinate. And then we think that our population success rate is, I think it was 92%, is 92%. Again, we're supposed to check all our conditions. We have samples. Share the screen. Now we're going to have samples, bags of seeds that are size 160. So we're supposed to check all those conditions. Look, it even says here, be sure to check the conditions. I'm not going to bother doing that right now. That's kind of the point of part B, is that maybe we don't meet the conditions. But let's go through the math without checking the conditions. So now I have samples. My N will be 160. I want to find up the probability that I get more than 95% germination. So I want my sample success rate to be more than 95%. Okay, so from our population, we need Q. We have an 8% failure rate. In the whole population, 8% fail to germinate. Bags of seeds or packets of seeds, that's what we're graphing out here. The samples will follow a normal distribution with the average germination rate of a bag equaling the population rate, 92%. I want to be at 95 or above. I need to calculate my standard deviation, square root of PQ over N. I want you to see right here how you could easily get confused typing stuff in here. I've got two different P's written on the board already. You got to be careful. These are the population numbers. 92.08 over 160. Let's type that in. So square root 0.92 times 0.08 divided by 160, 0.021. Okay, now I can find my z-score. Z-score is the one I want minus the one in the middle of my picture. That's why it's imperative that you draw the picture over that standard deviation we just calculated. If you want to do this all in one step without having to hit enter twice, you can always put that top in parentheses, 0.95 minus 0.92 divided by 0.021, I think it was. That's it. Always make sure your z-scores are reasonable. Remember, if you get a z-score like 30, you've probably goofed. There's like one question on a test we'll have later where you get a z-score of like 15, and literally the point of that question is where that was an outrageous claim. So most of your z-scores will usually be between, like, say, maybe -3 to 3, around in there. Here we get 1.43. Always round z-scores to 2 decimal places. So 1.43. Then normal CDF, smallest z-score to biggest. So I won't share the screen. I'm just going to type that in real quick. So 1.43 to 99. I got 0.07. 6. So then we would write a complete sentence because word problems have word answers. 7.6% of packets, not of all seeds, of size 160 would have a germination rate (95% or higher). Or we could literally just take the question itself and tack on, reword the question, tack on 7.6%. So the question was, what is the probability? So we could just say, the probability that more than 95% of the 160 seeds will germinate is 7.6%. Now, we do want to think about this. This collection of seeds I got here, these were not a random collection from all possible seeds. These were all in the same packet. How do we know this was a good sample? What if something happened to this packet? What if this packet got wet and that increased or decreased the germination rate? What if something happened to the packet and it no longer represents the whole population? That is something we would want to be at least a little worried about.